Consideration of electrical machine design. The thermal consideration we have discussed something in the last class itself, right? Thermal factors, that is the temperature, how the temperature has been raised, how it has been dissipated to the outer surface. So what is the importance of the thermal factor in the electrical machine, that we are going to discuss in the particular class. Okay. So the thermal consideration, normally we are having the machines, that is the rotating machines and stationary machines. If it is in the rotating machines, you can consider both motor as well as generator. In the stationary machines like transformer, you can consider any type of machine. It's have the two windings. One is the stator part and another one is the rotor part. In the case of transformer, it's have two winding. One is the primary and another one is the secondary. So wherever we are giving the energy or supply to the primary winding, so it has been transferred without any conducting medium, either rotor or secondary winding. If the rotor means, that is the rotating machines, it will come under the category of rotating machines. The transformer, the primary winding, after giving up supply, it has been transferred without any conducting medium. Generated EMF, it has been reached to the secondary winding, right? So while the energy conversion is occurring, so while wherever the energy conversion is taken place, so what it will happen now? So while the flux has been transferred from the primary to secondary, the induced EMF, there will be the losses, it should be considered. That losses, it has been dissipated in the form of heat. If you are consider the conducting medium, the conductor initially it have the internal resistance, right? So due to the internal resistance, it has been heat developed. Similarly, the insulating material, presence of rotating parts, the developed heat has been transferred from stator to rotor, and finally it has been dissipated to the outer surface. So it never has been increased beyond the ambient temperature, right? If it is the ambient temperature or melting point temperature, if it is 90 degrees Celsius, beyond that, if it is increased, what it will happen? The machine, it will be getting damaged. Okay, that is why the temperature we are considered the major part. So while the temperature, while you are selecting the insulating material or conducting material and loading capacity, this all you should consider, because after designing of machine, the temperature it should be the optimal one. Okay, that is the considered temperature or operating temperature. For example, 35 plus or 90 degree. Okay, so up to the 90 degree we can apply the load. After that, if we are keep on applying the load, due to if you are overloading capacity or any of load variation, the temperature also getting raised. That is why the many abnormal factors we discussed in the last class, right? So due to the short circuit and overloading of current, insulation failure, okay, and due to some drawbacks, any of drawbacks, due to any of abnormal factor, the temperature has been increased. So we try to avoid the design process itself. We need to avoid that issue. That is why the temperature consideration is essential one. So after while the heat is dissipated, now anyhow we can't avoid the temperature rise. Okay, so it should be the generated, because the conducting medium or conductor itself, it's have the internal resistance. The temperature increasing or temperature variation, we can't avoid it easily. So it is the considerable factor. So the developed heat, how it has been transferred to the one medium to another medium, it is the three process that also we keynoted in the last class itself: the conduction, convection and radiation, right? The conduction, in the sense, you can put any of steel rod or any of any material, any of winding from the one conducting medium into another medium. That means you can consider any of coil like this. So if that heat is transferred, heat is developed, so it's have the conducting part. So heat also conducting due to the process of conducting from one location to one area, one part into another part. That is the process of conduction. You are considering the two different variation of temperature. This is the equation, generic equation for the conduction, right? That is the theta 1 and theta 2. That is the theta 1 is the initial temperature, theta 2 is the final temperature. For initial temperature, for example, 10 degree. So the final temperature, it may be 35 means the increased temperature or conduction temperature is 25 degrees Celsius, right? So here that is the resistance, right? Thermal resistance. R theta is the thermal resistance. So the theta 1 and theta 2 is the temperature, the initial and final temperature, and theta, that is R theta, is the thermal resistance. Then the resistivity, we know that, so our thermal resistance R, it should be equal the rho into T divided by S. The rho is the resistivity, thermal resistivity, S is the surface of the medium, and T is the thickness, right? So this all factor it should be considered. If you are consider any conductor, there will be what is the resistivity of that particular conductor and what is the thickness of the conductor, what is the surface area of the conductor. So based on these all factors, you are considering the thermal resistance. Okay, that is also one of the essential factor during the temperature transferring process, that is the conduction process, right? So while if you are substituting these all values, so finally the equation getting modified. So the resistivity, we know that rho it should be equal to 1 divided by sigma, that is the 1 by conductivity, right? Similarly, you are substituting these all values and this expression here, the R we are replaced here, right? R we can replace rho T divided by S. Then the rho you can replace 1 by sigma. So if we are substituting all the expressions in the first one, finally we can get the expression like that, S into sigma into theta 1 minus theta 2 divided by T, right? Where S is the surface of the medium, T is the thickness of the medium, then the temperature, the initial temperature and the final temperature and the surface area. Okay, so what is the unit of this? Here the area we are considered, so the losses watt per meter square, right? That is the heat dissipation or temperature transferring process due to the conduction. Heat dissipation due to the conduction. Similarly, heat dissipation by the convection. Heat dissipation by the convection, here the constant of the hot body, that is the Kc is the constant of the hot body, the Q convection, that was the notation. Here also we are considered for initial and final temperature. Normally the heat is transferred from one medium to another medium, that was the initial temperature and final temperature we need to consider. That is why the temperature changes we can find it out easily. Okay, due to the heat flow or heat transferring process, the temperature has been varied from 0 to 25 or 0 to 35 or 0 to steady state temperature, right? So that is the three process. The first one conduction, similarly the convection also we are considered two different operating temperature, the theta 1 and the theta 2, that is the initial temperature and final temperature, and this is the n value, it should be lies between 1 to 1.25, right? Then the Kc is the constant of the hot body, that is the it is making the conversion process, no, that is the hot body. So we are considering the total surface, the Q convection into total surface, that is the total heat dissipation of the medium, right? Similarly the radiation, it's have the radiation majorly we are in the mechanical parts it may occur. So here it's the major law, that is the QR, it should be equal to 5.7 into 10 power minus 8. Then E is the emissivity factor here. Okay, due to because the radiation is totally different from the conduction and convection, right? The radiations, radiation, that is the emission, the heat emission, no, that is the heat is transferred through the air or due to the vibrations, like friction. Due to the friction the heat was developed, no, so that is the process of radiations, that is the emissivity factor. And T1 here also the temperature, T0 also the temperature, the initial and final temperature, that is the based on the law, it was the developed the equations. Okay, that was the final expression we are directly considered here. So this derivation itself, it is the larger one, that is the Stephen-Boltzmann law, that is the here initial and final temperature we are considered. Then the heat flow due to the heat dissipated in the radiation we are considered this expression. So finally we conclude that so the temperature is one of the essential factor to selection of insulating material and conducting material, and it has been occurred three different ways. One is the conduction, convection and radiation. So conduction is the process conducting the temperature, the convection is process also, that process also we can consider transferring the temperature from one medium to another medium. It's majorly it is considered in the liquid surface area, liquid area it may transfer the heat, but here due to the vibration and the mechanical stress, the radiation has been occurred, the temperature has been transferred. Majorly these three processes we are considered further in the case of heat flow. The heat is developed heat has been dissipated to the outer surface by these three methods. Okay, thank you. If you have